an easy, colorful way to find asteroids with astrophotography. This is the color shift detection technique. Here's the problem. There's an asteroid somewhere in this image, but where is it? You can do a blink comparison of several images to find it, or make a GIF movie to find it, but the following technique is easy, fun, and the resulting image takes up minimal memory. The first step in finding the asteroid is to optimize your field of view for your sensor. An angular field of view of about 0.3 degrees or 18 arc minutes for smaller sensor dimension works well. For a 3x2 sensor, for example, that's a field of view of about 0.45 degrees by 0.3 degrees or 27 by 18 arc minutes. Select your telescope focal length based on your camera's sensor size. A focal reducer may be necessary and very helpful to optimize your field of view. Shorter focal length means wider field of view, so you're less likely to miss your target asteroid, but the asteroid will move more gradually and traverse fewer pixels over time. A longer focal length means your target moves faster across the smaller field of view, but you might miss the target altogether, especially if the quality of your scope alignment is not optimal. To calculate an optimum telescope focal length, use the following formula. Focal length equals the smaller sensor dimension in millimeters times 56.2 divided by the smaller sensor dimension in degrees. For example, the smaller dimension of a 13.2 by 8.8 millimeter sensor is 8.8 millimeters. To produce a 0.3 degree field of view in this dimension, the calculated focal length is 8.8 millimeters times 56.2 divided by 0.3 degrees, which is about 1,650 millimeters, a range of about 200 millimeters between 1,450 and 1,850 millimeters is acceptable. Here are some good sources for asteroid information, including dates of opposition. There's the Astro Van Buitenen site, the BritAstro site, and inthesky.org. Current coordinates are critical once your telescope is aligned. Use sites with helpful coordinate data, ephemerides. 15 Eunomia is used as an example for the following websites: In the Sky or The Sky Live. Once you've picked your asteroid, step number 3, the next step, is to calculate the interval between image captures. Use the focal length and sensor data for your astrophotography equipment to calculate its resolution in arc seconds per pixel. The following formula is resolution in arc seconds per pixel equals 206 times pixel size in micrometers divided by focal length in millimeters. For example, if the pixel size of your camera is 2.4 micrometers and your telescope focal length is 1,650 millimeters, then your resolution is about 0.30 arc seconds per pixel. Continuing with this example, calculating the interval between image captures, the average angular speed of most asteroids is about 0.60 arcseconds per minute. To calculate the speed of the asteroid across your camera's sensor, use the formula speed in pixels per minute equals 0.60 arcseconds per minute divided by resolution in arcseconds per pixel. If we continue with the data in the current example, the resolution is 0.3 arcseconds per pixel, so the asteroid's speed across the sensor is 0.6 divided by 0.3, which is about 2 pixels per minute. Aim for at least 20 pixels of asteroid movement between image captures. 30 pixels is better, but requires slightly longer time intervals between image captures. If we continue the current example, for 30 pixels of asteroid movement between images at a speed of 2 pixels per minute, we get 30 divided by 2 equals 15 minutes between image captures for optimum separation. This brings us to step number 4, the actual capture of the images. Capture 3 to 4 monochrome images at the calculated interval. I've used these 4 images of 8 flora as an example. They were captured 15 to 20 minutes apart. In this example of 8 flora, here are the 4 monochrome images at the calculated interval in order. The fifth and final step is to combine the images using RGB, red, green, blue, if you have 3 images, or LRGB if you have 4 images. Helpful instructions for this technique are found at the AstroSurf website, also at the Stargazers Lounge website. A search of the internet will produce many other sites with helpful information on the RGB or LRGB technique. I use the technique on 8 flora, which I call the color shift detection technique. And sure enough, there it is. Here's an enlarged view of the same LRGB image of 8 flora. Here are other examples of asteroids detected with the color shift technique. This one is number 13, Egeria. This one is Eurynome. And here we have number 19, Fortuna. And here we have number 17, Thetis. This technique even works if you want to find Pluto, although because Pluto moves much more slowly, the images have to be separated by a longer time period. These images were taken over several days. I was unable to find Pluto until I used this image. So, go out, enjoy clear skies, and enjoy using this technique for finding and recording asteroids.